Hi everyone, this is Mr. Lee. In this video, we are going to go over 2D reference frames. So let's begin. So according to the last video, we came up with these rules for coming out with the subscript formula. So I had the four steps in front of you. Let's just go through this together. So the formula that we have to start off with is VAB is equal to V, right? And then we have two subscripts there, plus V, and we have the two subscripts there, okay? And so the subscripts that we're using is just like A, B, C, D, and alphabetical. So according to step 2, the first subscript is the first subscript on the first variable. So what that means is that the first subscript over here is going to be equal to the first subscript for the first variable. So this is the first variable, and that is the first subscript spot, so I'm going to put an A there. All right, second one, it says the second subscript is the second subscript on the second variable. All right, so that's a tongue twister there. So that's the second subscript, and the leftover V all the way on the right-hand side, that's the second variable, and we're going to put that over here. So that's going to be actually after the comma right there. So this will be B. Okay, and the leftover spots we're going to reserve for the subscripts that's supposed to cancel out. So here we have C and C. And so the important thing is that mathematically what happens is that the subscripts there and there, they'll cancel out. Okay, so just as an update on the wording, okay, so the first subscript is the object, and the second subscript is what I like to call the observer, okay? And the idea behind the observer is like, all right, so imagine that the observer is the stationary object. All right, so that's the formula, and now let's go into the 2D stuff. So whenever we do relative motion, sometimes it's going to be like in terms of like acceleration or maybe like velocity. So oftentimes we're going to look at it in terms of velocity. So with velocity, we know that velocity is a vector. So a vector has magnitude and direction. Okay, so that's MAG for magnitude. It's magnitude and direction. And so because it's a magnitude and direction, whenever we're doing 2D or two-dimensional vector addition, we can't just add up all of the x vectors with the y vectors, right? So this is not possible. Okay, no good. And so the technique that we've been doing is we have to use the Pythagorean theorem to find the overall vector. So what that means is if we have a x vector like so, and if we have a y vector like so, in order to add the x's and the y's together, so let's say this x is 3, this y is -4, in order to find the overall vector here, okay, we can't just do 3 plus -4, but instead we have to use the Pythagorean theorem, and if you do that, 3 squared plus 4 squared, and then the square root of that, that'll give you an answer of 5. And so the idea is still going to be the same for reference frames, okay? So let's do an example to see exactly what that means. All right, now this is a classic problem. We saw a similar problem like this in one of our practice problems from before. But let's say there's like a sandy bank or a beach or land, right? And then here you are the observer. Okay, and in between we have water, right? So here we have water, and the water has, I don't know, some like delta y that a boat has to cross, and we'll put a little boat right there. Okay, so we have a boat. So this is what we currently know. The subscripts that we're going to use is L for land, B for boat, and we'll use, I have in my notes, W for the water. Okay, so we have water here. All right, so let's think about this conceptually first. If the water is flowing with a velocity to the right, okay, so this is the current of the water, and the boat is headed towards land in this direction. Okay. If we were to think about it and we were to do vector addition, the vector addition would look like this for the boat. So we can say that if this dot represents the boat, we have the velocity of the boat, which is the y vector, and we have the velocity of the water, which is the x vector. And so the overall vector, or the overall speed or velocity of the boat, will have to take into account of both of those vectors. And so we get a hypotenuse situation, right? So if I were to turn this into a triangle, we would look something like this, all right, where this is VB and this is VW. Okay, and so if we use the Pythagorean theorem, we will get the overall velocity is equal to the root of VW squared plus VB squared. Okay, so this is how we would normally solve it if we're not using reference frames. But if we are doing reference frames, our math would look a little bit like this. So let me zoom out a little bit. There we go. Okay, so within this given problem, let's say the velocity of the water according to the land, okay, so the velocity of the water according to the observer on land is equal to 3 meters per second going to the right, all right? Let's say the velocity of the boat according to the water is 4.5 meters per second, okay, going vertically. So this is to say, like, if we were to pretend that the water is moving, or if we were to pretend that the water is still, the velocity of the boat would just be the boat moving upwards with 4.5, so like the speed of the boat. All right. So the question is, according to these two frames of reference, what is the velocity of the boat according to the land? Right. So essentially, what we're looking for is how fast is this motion, right? Because the observer on the land will not see the boat going straight up vertically, but rather will see the boat going off at an angle. So what is that velocity? Okay, so let's try this out.